All right, our final example is going to be f of x equals x squared minus 4x minus 5 over x minus 3. We're going to follow the same pattern. The first thing we're going to find is our domain. So let's talk about the domain. Well, the only thing that's going to make the denominator 0 here is 3. So x in this case cannot be 3. So we're going to have to eliminate that from our domain. And as long as that doesn't also make the numerator 0, that's also going to become our vertical asymptote. So if you look at the numerator, if you were to plug 3 into the numerator, it would not make the numerator 0. So we don't have a problem there. So this is also our vertical asymptote. The vertical asymptote is x equals 3. Let's look at the horizontal asymptote. Horizontal asymptote is by comparing the numerator and the denominator. Well, in the numerator I have a degree of 2, and the denominator I have a degree of 1. The numerator's degree is higher than the denominator, which means that there are no horizontal asymptotes. So in this case, there would be none. This thing is going to, the fraction will keep getting bigger and bigger and bigger as x gets sufficiently large. Now we have to ask ourselves, do we have a slant asymptote? And remember, the criteria was that the degree of the numerator had to be exactly 1 higher. Well, in this case, it is. So we are going to have a slant asymptote. So we're actually going to have to do a little bit of math here. We're either going to do long division or synthetic division. I'm going to go ahead and do the long division on this one. Feel free to do synthetic if that's the way you prefer to do it. So x minus 3 is on the outside. X squared minus 4x minus 5 is on the inside. And let's go ahead and perform the long division. So what do I multiply by x to get x squared? Well, that's x. So we'll multiply the x times the x, get x squared. Multiply the x times the minus 3, we'll get minus 3x. And we'll subtract. X squared minus x squared is 0. Negative 4x minus minus, which is plus 3x. So negative 4x plus 3x is minus x. Bring down the minus 5. Now what do I multiply by the x on the outside to give me negative x? Well, that's negative 1. So I'll plug in negative 1 on top. So negative 1 now times x minus 3 is negative x plus 3. And we can subtract. Negative x minus minus x is 0. Negative 5 minus 3 is negative 8. That's your remainder. I have nothing else to bring down, so the remainder doesn't really matter here. My slant asymptote now has the equation y equals x minus 1. The answer here is your slant asymptote. You just have to make it the equation y equals that. So that'll give us a way to graph our slant asymptote. Let's go ahead and find our x and y intercepts. X-intercepts are done by whatever makes the numerator 0. Well, that numerator can actually be factored. Be easier to do it. That's going to factor to x minus 5, x plus 1. And we're going to set that equal to 0, which means that x is either going to equal 5 or x is going to equal negative 1. So I have two x-intercepts in this case, the point 5, 0 and the point negative 1, 0. And then my y-intercept is what I get when I plug 0 in for all the x's. Well, if I plug 0 in for all the x's, I get 0 minus 5 over 0 minus 3. That simplifies to negative 5 over negative 3, which is 5/3. That will not be the easiest thing to graph, but that's what our y-intercept is. So the y-intercept is the point 0, 5/3. All right, let's go ahead and sketch this graph. Okay, let's go ahead and put a whole bunch of marks on here. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. We'll go 6 in every direction. And again, remember that these are just sketches, so just do your best. Okay, first thing we should graph are the not the intercepts, the asymptotes. So x equals 3 is our vertical. X equals 3 is right here, so we're going to make a dotted line vertically. I don't have a horizontal, but I do have a slant. The slant asymptote is y equals x minus 1. So that means I have a y-intercept at -1 and a slope of 1, which is 1 over 1. So up 1, right 1, up 1, right 1, down 1, left 1, down 1, left 1. So you get the idea, and you can kind of see the slanted line there. And there we go. There is our slant asymptote. Let's graph our intercepts if we have them. We do. We have several. So let's go ahead and make the graph green here. So we have an intercept at the point 5, 0, which is 1, 2, 3, 4, 5 to the right and 0 up. I have an intercept at -1, 0, which is 1 left and 0 up. Then I have a y-intercept at the point 0, 5/3. 5/3 is about 1 2/3. So it's a little bigger than, or a little less than 2, I should say. So right about there, so it's a pretty good approximation for that. Okay, so what you should see on the left-hand side here, I've got the 2 dots there in green. One of them is the x-intercept, one of them is the y-intercept. You should kind of be looking at this and saying, okay, I can see how it's trending. It looks like it's going to trend up to the right, which is the way it's going to trend. If you want to, pick values. Pick 1, pick 2, plug those in, see what this thing is doing. What I can show you is that it's going to be doing something like this, and it's going to start to approach its vertical asymptote. As a matter of fact, I'm going to make the vertical asymptote just a little bit taller here so that you can see that that's what it's going to approach. As we go to the left, it does not have a horizontal asymptote, it has a slant asymptote. So it's going to start to come down this direction. Again, you can plug in values, plug in -2, plug in -3, plug in -4. What you'll see is that this thing starts to come down this way, and it will start to ride along the slant asymptote. On the right-hand side, again, I'm going to make this slant asymptote extend it out a little bit further. There's only one point, but hopefully you can see how the trend is going to go. Again, if you pick some other values, pick like, let's see, 1, 2, 3, pick 4 and plug that in. That would show you some kind of a negative value, and what it would show you is that as this thing approaches the vertical asymptote, it's going to start to trend down. And then as it goes off this direction towards the right, it's going to eventually, this is not going to look as good, it's going to start to approach its slant asymptote in that direction. And that's what your graph would look like. Not the easiest one to graph there with the limited space that I have, but that's the general idea on what this thing looks like.